You can only control the VBB from the outside. So at that particular value of the VBB, when exactly the VC just crosses this value boundary, becomes negative with respect to the VB, immediately your transistor will go to the saturation region. So previously, what we have assumed, we are operating in the active region, provided this condition should not happen. So even up to this one, you can say it is almost in the active region. But as soon as VC becomes less than VB, your base collector junction becomes reverse bias, forward bias, and correspondingly the it enters into the saturation region. And that condition of VCB is given from this equation 5, 6, and 7 only. That is VCC minus VBE minus IC into RC plus RE plus RE by HFE, which is nothing but your VCB is less than or equals to 0. So practically, to ensure the transistor to be in the saturation region, what we actually follow, that minus VCB should be less than your V gamma, that is a cut-in voltage of the PN junction diode you're using at the base collector junction. So this particular condition you have to maintain if you want to go to the saturation region, that is, you want to make your switch on, or you have to be restricted yourself up to this condition if you have to make your transistor to be operated as an amplifier, because that ensures the last limiting point of the active region of operation. So if you can put it in a further mathematical fashion from these equations only, so the condition may be interpreted as just the simple equational solves that you can do from the 5, 6, 1 to 7 equations one by one. VCC minus VBE minus IC into RC plus RE plus RE plus HAV, VCB less than or equals to V gamma for practical situation. Less than 0 is always the ideal situation, but 0 to hota nahi hai. Usually after cut-in voltage only the transistor PN junction starts operating. So it is always depicted as less than minus V gamma. Hence from equations 3 and 8, we may directly write the collector current is should be follow greater than or equal to of this condition, equation 10. Note, when both base emitter and collector base junction are forward bias, the transistor is in the saturation region. Then the entire output, that is a collector to emitter region, becomes a low resistance path. So practically VC becomes a VC sat or nearly constant. So that's why we haven't gone for the calculation of VCE. We have focused on the calculation of VCB. In saturation region, the collector saturation current becomes, so this IC will become nothing but the IC sat, whose condition IC we have already discussed in the equation 10. So same equation 10 we have depicted here, which is nothing but your IC sat. And always we take this portion because your bare minimum IC should be greater than or equal to this one. So this actually becomes the IC sat value or the collector saturation value. So if you know, because VCC is known to you, VC sat for a transistor known to you, the resistance you have to apply from your thinking so that this condition is maintained. If you know this condition is to be maintained, then you can already know I should not increase my VBB up to certain, I should not increase the knob of my function generator so that VBB should not go beyond that value, so that the IC value does not cross, should cross this particular value if I want to operate my transistor in the saturation region. So in saturation region, IC also becomes nearly constant in IC sat, and it does not increase by the rule of IC equals to IHFE into IB with the base current anymore. So if you have all these handy calculations for you, when you brought the transistor from the market, you have the manufacturer's date sheet, almost all the values you have, then the tough equation job comes, you have to decide about these resistances to manipulate your equation for the pre-design in which operation region of operation you want to actually operate your transistor to maintain in the saturation region or cutoff region. As I told, the two extreme regions we have already calculated. One is the cutoff, the most negative one. Another is the saturation, the most positive one. In between, whatever the region left, that is nothing but your active region. So if VBB greater than VBE, so that it makes the base emitter junction to forward bias, then certainly the transistor cannot be in the cutoff region. We have already discussed the issue in case of a cutoff region. If equation 10, the last equation, that is has to be valid, is not satisfied, then the transistor can't be in the saturation region. Thus clearly VBB greater than VBE, but equation 10 is not satisfied, fine, your transistor should be in the active condition. So always when these kind of problems are given, you have to directly search for the cutoff region and you have to search for the saturation region. Cutoff region is very easy. You can immediately tell by checking the VBE values. The complications come when it is an active or saturation region. So you have to directly calculate equation 10. You have to calculate directly the equation 10 and equation 9 or equation 11. And for Toxi, you will be able in a condition to tell whether your transistor is in the active region or in the saturation region or in the cutoff region. So this is from the very basic thing. However, the things are quite complicated if I can ask you very logically. So suppose your transistor is in the saturation region, right? The problem you have been asked to find the transistor in the drive your transistor in the saturation region. From the equation 10, from the equation 11, all are in front of you. Can you comment what type of a value of your RC, RE, and RB you will choose? Not a particular value, I should be sorry. I mean, what relationship of RC and RE? RC should be very large or very small. RE should be very large or very small. RB should be of what kind of a range? Can anyone predict by just observing these equations? Because that is also a precise stuff. मैंने आपको बता दिया है कि equation आपको calculate करना है. But how do you calculate the equations? You have to have certain idea of RC. RC of 0.1 ohm से लेके infinite तक हर value put up करके तो नहीं देखोगे, because there are 3 distinct resistances. How many combinations will come? In C3 number of combinations will come, which is impossible. But if you can look very carefully, can anyone suggest what kind of a value or range of values RE and RB can be chosen to make the transistor in the saturation region? Just observe and try to think and let me know. Please, anyone.
Sir, RE much greater than RC.
Sorry. RE much greater than RC. Why? The logic behind this? आपने कुछ सोच के तो बोला होगा. What is the logic behind your such assumption? Maybe correct. I don't know, but why you are saying that? By the way, in the class, all are fine, health-wise fine till now.
हाँ जी सर, सारे बढ़िया.
Yes, sir.
अभी तक तो कोई दिक्कत नहीं है, so please be cautious. हाँ बताइए, what is the reason of your RE much greater than RC? कुछ तो सोच के आपने बताया होगा. What is the reason? Because your VCC, VBB, V gamma, all are fixed, HFE, all are fixed. If you look into the equation 10, IC greater than or equals to VCC minus VBB minus gamma by RC plus RE plus RE by HFE. So IC must have to be greater than that value. Any logic? सोचिए क्योंकि बिना इसके सोच के मुश्किल है during this semester. All will be such logical things so that you can perfectly design. When I will complete, we will do problems on the next class of this saturation and cutoff region, and then I will immediately give you one or two circuits, generalized transistor circuit, or even in this circuit, you have to simulate and you have to tell the precise values of RE, RB, RC, IC set ka kya ho raha hai, each and everything. You have to simulate through your multisim, and you have to give us a proper range कि इससे इस रेंज में ये एक्टिव रीजन में होगा, इसके बियॉन्ड ये सैचुरेशन में जाएगा, इसके नीचे ये कट ऑफ में जाएगा, each and everything. So you have to design a proper practical transistor switch. That's it. और रीजन ऑफ ऑपरेशन स्विच तो बाद में आएंगे, उसमें और भी कॉम्प्लिकेटेड चीजें हैं. रोल नंबर 1.
Yes, sir.
Roll number 2. Roll number 3.
3 present, sir.
Roll number 5.
Present, sir.
Roll number
Sir,
6.
sir.
Present, sir.
आदिराज बताइए.
Sir, 4 आपने बोला नहीं.
4. Fine.
Yes.
5.
5
Six.
present, sir.
Okay.
5 present.
6.
Present, sir.
7.
Present, sir.
8.
Present, sir.
10.
Present, sir.
11.
Present, sir.
12.
Yes, sir.
13.
Present, sir.
14.
Present, sir.
15.
Present, sir.
16. 17. 18. 19.
Present, sir.
20.
Present, sir.
21.
Present, sir.
22.
Present, sir.
23. 24. 25.
Present, sir.
26.
Present, sir.
Sir, 24 present.
कितना?
24.
27.
Present, sir.
28.
Present, sir.
29. 30.
Present, sir.
31.
Present, sir.
32.
Present, sir.
34. 3.
Present, sir.
34.
Present, sir.
35. Present 36. Present 37.
Present, sir.
38.
Yes, sir.
39. 40. Present 41. 42. 43.
Present, sir.
44. Present 45.
Present, sir.
46. 46.
Present, sir.
47.
Present, sir.
48.
Present, sir.
49.
Present, sir.
50. 51. 52.
Present, sir.
53. Present 54. Present 55.
Present, sir.
Satyajit.
Present, sir.
Sir,
Alright, think about the RB, RE, and RC and let me know.
sir, thought, sir,
Please,
thought one.
please,
I got.
please. Mhm.
Sir, RC should be greater than RB.
RC should be greater than RB. And why
Yes,
such
sir.
so?
So because while analyzing the equation in that case, we if we check through the denominator because the numerator gets fixed. So in the denominator part on the left hand side, RB plus HFE plus 1 into RE. So in the numerator HFE is there, we bring it down. So it becomes the same on both sides. The RE part is we cannot comment on that. So if we think that that is constant on both sides, so
Hmm.
and above part we take it as
So that
constants
the
and
left hand side will give you a particular IC value. That should be greater than the IC SAT value because your right hand side part is actually your IC SAT value. Correct?
okay.
So, and RB and RE is from the base emitter junction, and RC and RE are from the collector emitter junction. Rather than finding any relationship between RB and RC, because RB is from input side, RC is from the output side, you should find the relationship between either RC and RE, which is which are common in the output side. So
Okay, sir.
RB and RC relating is not that be fruitful rather than RC and RE. That is one hint.
Okay, sir.
Now you have to think of what RC and RE you will choose. I mean, which higher, which lower, whatever it is, which give you a preferable value. Think about it. We will come, or we may get it enough knowledge when we will come into the actual problem solving in the next class. Thank you. I will share the PPT and see you in the next week.
Thank you,
Thank you,
sir.
sir.
Meanwhile, please do the equation solving and the calculations.